Hi guys, so today I'm going to be going over the exam questions from the topic number. So this is every question from every topic in the number portion of the foundation module. So let's just get into it. Solve for the following: 7 times 8 divided by 4 squared. So this question is about BidMaths. So if you just write BidMaths in the corner. You can see brackets first, then indices, then division, then multiplication, then addition, then subtraction. In this case, we're going to be doing the brackets first. So just show it in step. It says show your work, so you need to show all the steps. So 7 times, I know 8 divided by 4 is 2. So we've done that bit. Next is indices. So the indices part is going to be, this bit here. So I can see 7 times 2 squared is 4. And then the last is multiplication. 7 times 4 is 28. So my answer is just 28. Moving on, write brackets in this statement to make each statement correct. So again, it's to do with BidMaths. It's a bit of a guessing game, but these questions come up quite frequently. So we need to make each of the statements true. So I'm going to add a bracket here first. So let's see how that makes sense. 2 plus 7 times 3 plus 4 equals 51. If I just solve it on the side, 2 plus 7 times 3 plus 4 is 7. Should equal 51. So now I can do the time multiplication bit next. 2 plus 7 times 7 is 49. And 2 plus 49 is 51. So that bracket's right. Second bracket, 4 times 3 plus 2. I'm going to add a bracket here because I know I need to get to 20. So now 4 times 3 plus 2 is 5 is 20. So that's correct. Right, the last one, I need to make 16. So I know 9 minus 7 is going to be 2. And I know 3 plus 5 is going to be 8. So 9 minus 7 is 2. And then I'm going to times that by 3 plus 5 is 8, which is 16 indeed. So that's right. So as long as you can see where the brackets go, you can sort of do a bit of trial and error. Next question. Work out minus 5 minus 12 and 7 minus 9. So you need to remember, when you have two minuses that are in the middle together, it equals a positive. So the minuses have to be in the middle together. And we can see there's a minus here, 2 minuses here, and 2 minuses here. So minus can also be negative, like a negative 12, as long as they're in the middle. So that's going to equal minus 5 plus 12, which equals 7. That's going to equal 7 plus 9, which is just 16. A lot of these questions in the number portion of the foundation spec is non-calculator. So they mainly come up in your non-calculator paper. So try doing these without a calculator. So a bit of a worded question. The table shows the temperature at midnight and midday on January 2nd, 2020 in 4 cities. One thing to remember with temperature that kids tend to get confused is the hotter the temperature is going to be higher. So the higher the temperature, the hotter is going to be. The lower the temperature, the colder it's going to be. For example, 30 degrees is hotter than 2 degrees. Minus 10 degrees is colder than minus 1 degree. So think of it logically when you're reading the weather or when you're looking at the news channel. The more negative the answer, the more negative the temperature, the colder it is. So just remember that. Write down the name of the city with the lowest midnight temperature. So we want the lowest midnight temperature. So we're looking at this section here. So the lowest midnight temperature I can see is Murmansk because it's minus 9 degrees. Which city had the greatest rise in temperature from midnight to midday? So for this question, we need to look at the difference between midnight and midday. So I can see Murmansk went from -9 to -6, so it increased in 3 degrees from midnight to midday. Budapest went from -3 to +4, so it increased 7 degrees. Paris went from 4 degrees at midnight to 8 degrees midday, so it increased in 4 degrees. And Prague went from -4 degrees to 1 degree, so it increased in 5 degrees. So we can see the one with the greatest temperature and rise in temperature is Budapest, because it increased +7 degrees. At midnight, how many degrees colder was Murmansk than Paris? So at midnight was Murmansk than Paris. So we need to work out the difference between -9 and 4 degrees. So Murmansk was -9 degrees. To get that to 0 degrees, we're going to +9. And then we want to get to 4 degrees. It's +4. So 9 plus 4 is just 13 degrees. So it increased in 13 degrees. It went up by 13 degrees. That's the difference. Okay, so moving on to next topic. This is factors and multiples. So Barry is thinking of a number. He says, my number is even. So his number is even. It is a factor of 30 and a multiple of 5. There are 2 possible numbers Barry can be thinking of. Write down these 2 numbers. So with this question, you just have to write everything down and see which number satisfies all 3 conditions. So let's first do the multiples of 5. Multiples of 5 are just the times tables of 5. So it's going to be 5, 10, 15, 20, 25, 30, 35, 40. I'm just going to write a few. So we've done multiples of 5. Now factors of 30. Factors just mean 2 numbers that times together to make that number. So I know it's 1 times 30, 2 times 15, 3 times 10, and 5 times 6. They're the only factors of 30. And so we've done them 2 now. The number has to be even. So all we need to do now is look for which 2 numbers are even. So I can see 10 is even. 10 is even. 15 is not even. 20 doesn't exist. The next even number is 30. So the 2 numbers that he's thinking of is 10 and 30. It's just a case of writing everything down, and then you can visually see what your numbers are. Ian says 21 is a prime number. Is Ian correct? So again, this is a proof question. So a prime number is a number that can only be divided by 1 and itself. So let's look at the factors of 21. Let's see what numbers times together to make 21. So I know 1 times 21. I also know 7 times 3 equals 21. So therefore, you must give a reason. My reason is, no, it is not a prime number, as it can be divided by 7 and 3. So therefore, it isn't a prime number. Moving on. Write 240 are the product of its prime factor. So we need to do a prime factor tree. So how you do it is, each time you break the number down into its factors, if you reach a prime number, you circle it. So I know 240 is, there's many ways to do it. There's no wrong or right way. So whichever way you choose, whichever factors you choose, you'll still get the same answer. 2 times 120. I know 2 is a prime number, so I'm going to circle that. 120 is 10 times 12. I know neither of these are prime numbers. 10 is 5 and 2. Both of these are prime numbers. 12 is 6 times 2. I know 2 is a prime number, and 6 is 3 times 2. Both of these are prime numbers. And then you need to write them in order. This is how you display it. So 2 times 2 times 2 times 2 times 3 times 5. And you can simplify it further by writing 2 to the power of 1, 2, 3, 4, because 2 occurs 4 times, times by 3, times by 5. So this is the correct way of writing it. It's the simplified way of writing it. Next question. Find the highest common factor of 84 and 120. So there is two ways to do it. There's the factor way, which you draw the you write on all the factors of both numbers, but it can get quite long because with big numbers like 84 and 120, you might miss some out. So I prefer doing the prime factor way and the Venn diagram way. So how you do this is, first I'm going to break each number down into its prime factors. So 84 is 2 and 42. I know 2 is a prime number, and 42 is 2 and 21, and 21 is 7 and 3. So I've broken that down. So I can say 84 equals 2 times 2 times 3 times 7. I'm going to do the same for 120. 120 is 10 times 12. 10 is 5 times 2. They're both prime numbers. 6 and 2. 3 and 2. So I've broken them down. 120 equals 2 times 2 times 2 times 3 times 5. So I've done both of them. Now you need to draw a Venn diagram. So I'm going to draw a Venn diagram. 84 is going to go here, 120 is going to go here. So in the middle here, you're going to add the numbers first that are common in both of them. So I'm just going to tick them all off as I'm going. So I know 2 occurs in both of them. I can see another 2 that's common in both of them. And then I can see a 3 is common in both of them. On what's left in the 84 prime factor tree is just 7. What's left in the 120 prime factor tree is another 2, which is extra, and 5. So now that I've split it into its Venn diagram, the highest common factor is basically everything in the middle multiplied together. So it's going to be 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So my highest common factor is 12. You can also find out the lowest common multiple from here. So the lowest common multiple is going to be everything everything in this in this Venn diagram and everything in this Venn diagram. So basically everything in the table times by together, multiply together. So it's going to be, so the LCM is going to be 7 times 2 times 2 times 3 times 2 times 5. If I just work that out, give me a second. 7 times 2 times 2 times 3 times 2 times 5, 840. That's what the lowest common multiple is. So I prefer the Venn diagram way because you know your answer is always going to be right. Okay, moving on. This question is a bit of a worded one, so again it's the same topic. So the question says, 2 buses, bus A and bus B, both use the same bus stop. Bus A runs every 10 minutes and bus B runs every 14 minutes. Both buses are at the stop at 11 a.m. What time will both buses next be at the bus stop? So when are they both going to be at the next bus stop? So this is, for this question, for these type of questions, you always need to work out the lowest common multiple. So you want to work out the lowest time that they're going to collide, and then you can work out the time from there. So I'm going to do the prime factor trees of both of them. I know 10 is 5 and 2, they're both prime numbers. 14 is 7 and 2, both prime numbers. I can put them in a Venn diagram. Both of them have 2. And then in the 10 Venn diagram, I could do 5, and then 14 I can add 7 here. So now I've drawn it. To work out the LCM, Remember, it's everything in this Venn diagram multiplied by everything here. So everything in the Venn diagram essentially. So the LCM is going to be 2 times 5 times 7, which is equal 2 times 5 is 10, 10 times 7 is 70. So the next time they're going to stop is after 70 minutes. So we found out what it is. So now both buses are at the stop 11 a.m. What time will they both be at the next bus stop? So we know after 70 minutes they're going to both be at the next bus stop. So I can do 11 a.m. plus 70 minutes. 70 minutes is just 1 hour, 10 minutes broken down. So I know 11 a.m. plus an hour is 12 p.m. 12 plus 10 is 12:10. So the next time they're going to be together is 12:10 p.m. Moving on. So this is to do with decimals. So timing decimals without a calculator. So when you're timesing a decimal times by a decimal, what you need to do is you need to get rid of the decimals first. So I can do 906 times 79. That makes it more easier to work out. I can work that out. I can work that out. 900, 0 and 6, 70 and 9, and I'm multiplying. You can multiply either the long multiplication method or the column method. I prefer the column method. So 900 times 70 is just 9 times 7 is 63. Add 1, 2, 3 zeros. 70 times 0 is just 0, and then 70 times 6. 7 times 6 is 42. Add a 0. 9 times 9 is 81. Add 2 zeros. That's going to be 0. 9 times 6 is 54. And I can just add them all up together. So I am adding these together. So 63, 1, 2, 3, add 8,100, add 420, add 54. I just add them up. That's going to be 4. 5 plus 2 is 7. 4 plus 1 is 5. 8 plus 3 is 11. So I'm going to carry 1 over. 6 plus 1 is 7. So I can see I've got 71,574. So one thing you have to remember is, because we took the decimal places out, you have to put the decimal places back in. So I can see there's 1 decimal place, 2 decimal places, 3 decimal places. So I can put the decimal point 1, 2, 3, 3 decimal places back in. So the answer is going to be 71.574. So when you're timesing a decimal times a decimal, take the decimal place out and then put it back in. The second scenario is when you're dividing a decimal by a whole number. And with this, you can just do it straight. You don't need to take the decimal places out. And I'm going to use the bus stop method. So 9 goes on the outside. 33.84. And remember, the decimal place, it has to align with the numbers on top. I can see, so I'm going to do how many times does 9 go into 3? 0. So I'm going to carry the 3 over. How many times does 9 go into 33? 9, 18, 27. So that's going to be 3 times. And the remainder is going to be 6. How many times does 9 go into 68? That's going to be 7 times. And the remainder is 5. And then how many times does 9 go into 54 is just 6. 9 times 6 is 54. So I can see 33.84 divided by 9 is just 3.76. So that's fairly straightforward. And then the last scenario is when you're dividing a decimal by a decimal. So the easiest method to do this is by getting rid of this decimal. And how you do that is, I'm going to write them both as fractions. So what I'm going to do is, I want to get rid of the decimal on the bottom. So you can only get rid of a decimal on the denominator by timesing it by either 10, 100 or 1,000, depending on how many decimal places it has. This only has 1 decimal place, so therefore I'm going to times both number by 10, because the 0 correlates to how many decimal places. So that's going to become 186 divided by 8. And now I can just work that out using bus stop method. 186. 8 can't go into 1, therefore 0. How many times does 8 go into 18? 8 16 twice, and the remainder is 2. How many times does 8 go into 26? 3 times. Need to add some zeros because there's going to be remainders, and make sure you align the zeros up. 8 goes into 26 3 times, and the remainder is 2. How many times does 8 go into 20? 8 16 twice, remainder 4, and 8 goes into 45 times. Therefore, the answer is 23.25. That's how you do that one. So just remember, when you're dividing by a decimal, the most common way to do it is get rid of the decimal first, and then just divide it. If I had something like 18.6 divided by 0.008, I can see there's 2 decimal places, therefore I'm going to times the bottom and the top by 100. So whatever decimal places are, that shows you how many times you need to times it by 10, 100, 1,000, 10,000. Right, moving on to fractions. Fractions work out 2/5 plus 1/7. You can't do anything with mixed numbers, so you need to convert them to improper fractions. So 2 times 5, add 1. So 2 times 5 is 10, 10 add 1 is 11, 11 divided by 5, plus 7 times 1 is 7, add 1 is 8 divided by 7. Give your answer as a mixed number in its simplest form. So we need to give it as a mixed number. So first we're going to do 11 over 5, add 8 over 7. So get the denominators the same to add fractions. I can see a common denominator in both of them is 35. 5 times 7 is 35, so therefore 11 times 7 is 77. 7 times 5 is 35, therefore 8 times 5 is going to be 40. Now we can just add them together. 77 add 40 is 117 divided by 35. And I need to give it as a mixed number. So how many times does 35 go into 117? So we can see 35, 70, and 105. That's going to be 3 times, and the remainder is going to be 12 divided by 35. Next question, again, that's in its simplest form, that's right. Work out 1/6 divided by 2/3. I need to convert this to a mixed number, improper fraction first. So 6 times 1 is 6. Add 1 is 7 divided by 6 divided by 2/3. So remember, when you're doing dividing fractions, is keep, change, flip. So you keep the first fraction, change the sign to a time, and flip the second fraction. Now I can just time them across. 7 times 3 is 21. 6 times 2 is 12. And if I wanna simplify this, I can divide the top and the bottom by 3. 21 divided by 2. 21 divided by 3 is 7. 12 divided by 3 is 4. And if I want to change this into a mixed number, how many times does 4 go into 7? Just once. Remainder is 3 over 4. That's how you do adding and dividing fraction. And remember, if you get mixed numbers, always convert them to improper fractions first. Next question. Question 13. So last year the cost of Tom's train ticket was £42. This year the cost of Tom's train ticket increased to £50. Write down the increase in the cost of Tom's ticket as a fraction of last year's cost. So first of all, we need to know how much it increased. So you work out the difference. So you're going to do £50 minus £42. So we can see it increased by £8. It went up by £8. And it says write down the increase. So the increase was 8 as a fraction of last year's cost. Last year's cost was 42. That's all it is. And then just simplify it. Divide it by 2. Divide the top and the bottom by 2. 4/21. That's your answer. It's just about reading the question. Next question. Here are two fractions. Work out which of the fraction is closer to 1. This is a very common question that I've seen. So first of all, we need to get the denominators to be the same, because we can't tell what's going to be bigger or not. So I can see a common denominator is going to be 42. 6 times 7 is 42, therefore 7 times 7 is going to be 49. 7 times 6 is 42, therefore 6 times 6 is 36. Now I can see which is going to be bigger or smaller. So we can see it's out of 42. Whenever they give you the number 1, 1 is like saying 42 divided by 42. 42 divided by 42 is just 1, so you can rewrite it as 42 divided by 42. It's the same as writing 1. 1 can also be written as 6 divided by 6, 7 divided by 7. So we need to see which of them is closer than 42 divided by 42. Okay, so how we do that is, we're going to work out the difference. 49/42, take away 42/42. We're going to work out the difference. That is 7/42. That's for that one. And this one here, 42/42, take away 36/42. So just working out the difference is 6/42. I can see this is the smallest one, that's going to be more closer. Therefore, so make sure you write your reasoning. 6/7 is more closer to 1. So moving on. There are 924 people in the theatre. 383 of the people are men. 356 people are women. 2/5 of the children are boys. Work out how many girls there are. So first of all, we're going to do the total, which is 924. We're going to take away the men, which was 383, and we're going to take away the 356. So we're adding these two together to work out how many men and women there are all together. We're going to take away from the total. So I can see that is 924 take away. If you add these up together, 739. And if you work that out, 924 take away 739 is 185. So that's how many children there are. So we minus the men and the women, we've got the children left. So now what it says is 2/5 if 2/5 are boys, that means 3/5 are going to be girls. Because if the total is 5, if 2 of them 5 is boys, 3/5 is going to be girls. So all we need to do is work out 3/5 of the amount of children to work out how many girls there are. So how you do that is you do 185 divided by 5, and then you times by the top number. So we need to work that out. 185 divided by 5, long division. 5 can't go into 1. 5 goes into 18 3 times, and the remainder is 3. 5 goes into 35 7 times. And then we're going to do 37 times 3. I just like to add 7, 14, 21. Carry the 2, 3, 6, 9, 10, 11. Therefore, 111 are girls. There you go. Moving on, 16. So Harry has 50 sweets. He gives 2/5 of the sweets to Sandra. He gives 3/10 of the sweets to Jamie. He keeps the rest for himself. Work out how many sweets he keeps. So essentially, we need to work out 2/5 of 50, which is just 50 divided by 5. Times by 2. 50 divided by 5 is 10. 10 times 2 is 20. That's how many sweets he gives to Sandra. We do the same thing for how much he gives to Jamie. He gives 3/10. So we need to work out 3/10 of 50. So again, 50 divided by 10 times by 3. 50 divided by 10 is 5. 5 times 3 is 15. That's how many he gives to Jamie. He keeps the rest of the sweets for himself. So we're going to do the total, take away these two added together. And that equals 50 take away 35. So he keeps only 15 for himself. So it's just about reading the question. So fraction, right? 0.003 of the fraction. So we're going from a decimal to a fraction. And how you do that is, first of all, that is 0.003 over 1. And we want to do it as a fraction. So we need to basically get rid of the decimal. So I can see there's 1 decimal place, 2 decimal place, 3 decimal place. Therefore, I'm going to times the top by 1,000. And I'm going to times the bottom by 1,000 to get rid of the decimals. So if I times it by 1,000, the decimal place moves 1, 2, 3. It moves here. It becomes 3 divided by 1 times 1,000 is just 1,000. So there's my fraction. So always look at how many decimal places there are and how many jumps you need to do, and then either times that by 10, 100, or 1,000. Next question. Tom and Jerry both earn the same monthly salary. Each month, Tom saves 35% of his salary. Jerry spends 3/5 of his salary and saves the rest. Again, fraction. So if he spends 3/5, he's going to save 2/5. Because a total 3/5 as 2/5 is 5 or 5, which is one of the total. So you always work out the difference to work out the opposite. So if he's going to save, to work out who saves the most each month. So we're going to get them both as percentages. So we know how much he saves. So we're just going to convert 2/5 as a percentage. So we're going from a decimal to a percentage. So first you do decimal, we're going from a fraction to a percentage, to do fraction to decimal and decimal to percentage. So I'm going to do 5 divided by 2 first. 5 can't go into 2, so I'm going to carry it over. Carry the 2 over. How many times does 5 go into 24 times? So I can see that is 0.4, and then to get it as a percentage, just times it by 100, because percent means 100, and that is going to be 40%. So that's how much Jerry saves. So we can see if Jerry saved 40%, Tom saved 35%, we know saves more. Jerry saves more than Tom. So make sure you always write your reasonings. Next question. Convert 5/6 to a decimal. So we go from a fraction to a decimal. Fraction to a decimal, you're just using the bus stop method and you're actually dividing it. 6 goes on the outside, 5 goes on the inside. Remember to add a decimal point after the number and some zeros. Can 6 go into 5? No, it can't. And I'm going to carry the 5 over. How many times does 6 go into 5? 6, 12, 18, 24, 30, 36, 42, 48. That's 8 times. Remainder 2. How many times does 6 go into 26, 12, 18? 3 times. Remainder 2, 3 times. Remainder 2, 3 times. So I can see it's 0.8. 3, 3, 3, 3, 3. And we can see this bit is the recurring bit. This bit is the recurring part. So whenever you get a recurring part, the number that's recurring, you always put a dot on top. So that basically shows that it's recurring. So continuing on from the next question, write down the value of the 5 in the number 583.2. So it's place value. So if I write down 583.2, units 10, hundreds. So the value of 5 is 500. That's the value of 5 is 500. 8 would be 80 tens. 3 would just be 3 units. Next question, write this number to the nearest 1000. So if I'm just writing down, that's units, tens, hundreds, thousands, 10,000, 100,000. So I can see my place value, and we want to write it to the nearest 1000. We're going to be looking at that. So when you're rounding, you always look at the next number on the right. If that's bigger than 5, we round up. If the number is less than 5, we keep the number the same. I can see 7 is bigger than 5, so we round 4 up. That's going to become 385,000. There you go. So when you're rounding, the numbers on the right become zeros, and then the numbers on the left stay the same. So just remember that. That's rounded to the nearest 1000. Question 22. Write 90,437 correct to two significant figures. So remember, the first significant figure is going to be 9, 0, second, 3, 4, fifth. With significant figures, you can have zeros in the middle of whole numbers, but you can't start with zeros. So if we're writing that to two significant figures, 90437, that's my second significant figure. I look at the number on the right always. 4 is smaller than 5, therefore the 0 stays the same. So that's just going to become 90, 1, 2, 3. 90,000. Next number, next question. Phoebe pays 2.8 pence per minute to use her phone. On average, Phoebe uses her phone for 77 minutes per day. She pays her phone bill for 29 days. Work out an estimate for how much Phoebe pays. So but this is to do with estimations. So you don't need to give whole numbers. You need to use rounded numbers, so more manageable number that you can use without a calculator, because this question will definitely be on a non-calculator paper. So with these questions, you always round to one significant figure. So always round to one significant figure. So I can see 2.8, she pays 2.8 pence. So if I'm rounding that to the first significant figure, there's my first significant figure. Look at the next number. I'm going to round it up to 3. That's going to become 3 pence. She uses the phone for 77 minutes a day. I'm going to round that. That's my first significant figure. I'm going to look at the next number on the right. Therefore, 7 is bigger than 5. So that's going to round up to 80 mins per day. And my last number, she pays her phone bill for 29 days. I'm going to round that. That's my first significant figure. Look at the next number. That's going to get rounded up to 30 days. So I've got more manageable numbers now. Work out for an estimate for how much she pays. So if she's using her phone, if she's paying 3 pence per minute and she's on the phone for 80 minutes, and then she pays her phone bill for 30 days. 3 times 80 times 30. So I can do 3 times 8 times 3. 8 times 3 is 8, 16, 24. 24 times 3 is 72. And just add the zeros in 1, 2. So that's how much she's paying in pence altogether. Okay, so that's answer to part A. Now part B, is your answer to part A an overestimate or an underestimate? Give a reasoning. With this question, if it's an underestimate if you rounded all your numbers down or kept the same. If you rounded all your numbers down or kept the numbers the same. Overestimate if you rounded all your numbers up. In this case, we went up here. We rounded up here. And we also rounded up here. So therefore, my answer is an overestimate as I rounded all my numbers up. So just remember that if you've kept it the same or rounded down, that's an underestimate. Overestimate if you rounded all your numbers up. Right, error interval. A number y is rounded to one decimal place. The result is 19.3. Write down the error interval. Error interval is basically saying, before rounding, what's the range in which the number can be before it gets rounded up. So how you do this question is, I always do a number line and I put 19.3 in the middle. And then I always do the next number up. So 19.3 add is going to be 19.4. And the next number down is going to be 19.2. Because it's rounded to one decimal place. So therefore you're going to add one decimal place up, one decimal place down. And your error interval basically lies in the middle of these two. So my error interval is going to be between them two. So what number is between 19.3 and 19.4? 19.35. What number is between 19.2 and 19.3? 19.25. That's my error interval. So depending on how many decimal places is rounded, you add one and then minus one, and then your error interval lies in between them two numbers. And how you write it is 19.25 35. So what that basically saying is 19.3 is bigger than or equal to 19.25, which is, and then 19.3 is also less than 19.35. If it was 19.35, we'd round it up to 19.4, but it's not, it's less than that. So there's my error interval. And it's always the same format. Do a number line and in between. And then now last few questions. So we're moving on to laws of indices, powers and roots. So question A. Simplify 5c squared d cubed times 2d. So you have to think which ones are the like terms. 5 and the 2 are both whole numbers, so they're your like terms. C is its own term because there's no c on the side, and then we've got d and d here. So we can only simplify the like terms. And when you're timesing, you add powers. That's the laws of indices. So for example, a squared times a cubed is going to be a to the power of 5, because we're timesing the same like term and then you add the powers. So I can see 5 times 2 is 10. C squared, we've got nothing to times that by, so that's going to stay the same. D cubed times d to the power of 1. There's always a secret of 1 if nothing is written. So when you time, then you add the powers, so that's going to be 3 plus 1, so d to the power of 4. So that's that simplified. Part B, write 64 times 4 to the power of 5 as the power of 4. So you're basically writing everything as the power of 4. This is already at the power of 4. We need to write 64 as the power of 4. I know 64 is 4 cubed, because 4 times 4 times 4 is 64. So I've written that as the power of 4. Now I'm going to rewrite it. 64 as 4 cubed times 4 to the power of 5. I'm just rewriting that. And now when you're timesing, you add the powers, that's going to become 4 to the power of 3 plus 5, which is 8. So it's written as the power of 4. So this question, 25B, is a very common question that kids get confused. They won't ever give you a number that you can't write as that power. So it'll always be a number that you can't. So just rewrite it. C, simplify p cubed times p to the power of 5 squared. When you have powers in brackets, the rule is you times them. So for example, a to the power of 1 times 2 is going to be a to the power of 1 times 2, which is 2. So powers in brackets is powers on the outside of brackets, you times them. So that's going to become p to the power of 3 times p to the power of 5 times 2 is p to the power of 10. And now I can just use this rule here, times if it's time you add the power, that's going to become p to the power of 13. 26, again simplify. We can see like term here, p here, q here, and then we have r here. So we've identified the like term. So now let's simplify. 10 divided by 4 is simplified to 5 divided by 2. When you're dividing, you minus the powers. P to the power of 3 divided by p to the power of 3, you take away the power. So 3 take away 3, which is 0. So we're left with nothing. They cancel out. Q to the power of 5 divided by q to the power of 6 is 5. So remember, it's the top power take away the bottom power. 5 take away 6, which is just minus 1. So I'm going to leave q to the power of 1 on the bottom. Because that's simplified, and we're left with 1, and then we're left with r here. And then that is simplified. So that's going to be 5r divided by 2q. Okay. Now, last topic in the number section is standard form. Writing standard form, timesing, dividing, adding and minusing. So question 27. Write this number in standard form. So when you're writing in standard form, you have to remember the format is a times 10 to the power of n. A has to be a number between 1 and 10. It can't be 0 and it can't be more than 10. It has to be a number between 1 and 10. And then n is your power, and n tells you how many times the decimal place moves. So with n, the bigger you go, so the bigger your number becomes, the positive it is. The smaller your number goes, or the more negative it goes, smaller your number goes, is a negative power. Your power goes more negative. So first of all, we can see we need to write that 429000123. So I need to first make a number, put the decimal place somewhere where the number is between 1 and 10, and I can see it's going to be here. That's going to become 4.29 times 10. And let me work out how many places I moved the number, the decimal point, 1, 2, 3, 4, 5, 6, 7 places. So it went from here to the middle, so it moved 7 places. That becomes to the power of 7. So 4.29 times 10 to the power of 7. And if you ever want to check and you ever want to work it out, if you move the decimal places 7 places that way, it should give you your original number. Or if it's in a calculator paper, if you put it in a calculator, it should give you your original number. Okay. Part B, write 3.61 times 10 to the power of 3 as an ordinary number. So 3.61, because it's negative, the number, the decimal point is going to move to the left. So it's going to move 3 places to the left. 1, 2, 3. So it's going to go here. I'm going to replace the whole with zeros. That becomes 0.00361. So if your power is negative, it moves, the decimal point moves to the left. If your power is positive, the decimal place moves to the right. Okay, now question 28. Work out the value of 5 times 10 to the power of 3 times 6 times 10 to the power of 7. So when you're timesing, standard form numbers, what you do is, so the general rule is you times your whole numbers and then you times your powers, and that's the indices rule that comes into play. So I can see what I'm going to do is 5 times 6 times 10 to the power of 3 times 10 to the power of 7. I can work that out. 5 times 6 is 30 times, when you're timesing, you add the powers. When you're timesing, numbers with the same base. So that's going to become 3 plus 7, so 10 to the power of 10. But one thing you have to remember is, you have to check, is this in standard form? So standard form, the number A, so the first number has to be between 1 and 10, and this is not in standard form because 30 is bigger than 10. So we have to convert it into standard form. So we can see the decimal point is going to be there. I'm going to move it one place here. That's going to become 3.0 times 10, and then you're going to add 1 because the decimal point moved one more place. 10 to the power of 11, and that is in standard form. And now 1 divide. 3 times 10 to the power of 4 divided by 6 times 10 to the power of minus 3. Again, with timing and dividing, you times and divide the number. So 3 divided by 6 times 10 to the power of 4 divided by 10 to the power of minus 3. 3 divided by 6 is 0.5. And then when you're dividing, you minus the power. So 4 take away minus 3, which equal positive 7 because the two negatives make a positive. 10 to the power of 7. And again, you have to check, is it in standard form? It's not in standard form because this number is not between 1 and 10. So 0.5 is going to move one place here to make 5. And I'm going to minus 1 from there. So 5 times 10 to the power of 6. That's my answer. Now last question is adding. Adding and minusing is the same concept. There's two ways you can do it. The first way is you write each of these as their original numbers and you add them and then you put it back into standard form. I'm going to do it that way. So I'm going to write them both as they're not the original numbers. So 2.6 times 10 to the power of 6. So 1, 2, 3, 4, 5, 6. That becomes 2,600,000. And same thing I'm going to do with that. 7.1 times 10 to the power of 5. So I'm going to move the decimal place 1, 2, 3, 4, 5. And that becomes 710,000. So I can just add them. So I'm going to just do long addition. So I'm just going to add them here. So 0, 0, 0, 0, 1 add 0 is 1, 7 add 6 is 13. And I'm going to carry 1, 2 plus 1 is 3. So I've got 3, 3, 1, 0, 0, 0, 0. That's my final answer, but I need to give my answer in standard form. So I'm going to put it in standard form 1, 2, 3, 4, 5, 6. So 3.31, so this is between 1 and 10, times 10 to the power of, I moved the decimal point 1, 2, 3, 4, 5, 6 times. There's my number in standard form. I say that's the easiest way to do it. Write your numbers as original numbers and then convert it back into standard form. So these first 30 questions were the whole number topic, one of each topic. So yeah, okay.